So now in this video we're going to wire up a flip-flop circuit, demonstration flip-flop circuit with the SN74HC00N integrated circuit. And so what this is a quad 2-input positive NAND gate integrated circuit. So there's 4 NAND gates that operate when they get a positive signal to the pins. We will look at that coming up, but in any case, we have the output of 2 of the NAND gates with a yellow jumper there. So you can see we got a little too close. There we go. So 3rd pin down, we have a jumper that goes to an LED, and then 3 more pins down, so 1, 2, 3, we have the other output right there. So we have 2 inputs for the output of this NAND gate, and we have 2 inputs there for this output of that NAND gate. And now we will zoom back. We have loads here, LEDs with protective resistor. These are 1 kilo ohm resistors, and I'll turn the power on, and now you can see that both LEDs are on. The output is high for both of them. Right now the inputs are floating. So we have a jumper that goes from 1 input of each of the NAND gates to the switch, and the switch is open, so nothing's happening. If I press the switch, then we connect to ground. We actually get a 0-volt signal to the pin. Now what we're going to do is take a couple 10 kilo ohm resistors, and where the jumper comes, put it to the positive rail. So now we're actually getting a positive 5 volts to the pin. We don't need any current, it just sees that we're connected to the positive rail unless we push the switch. Then it connects directly to the negative rail. Whatever current gets through the resistor gets sucked to the negative rail, and so the pin just sees the negative rail electrically. We're going to do that with both switches right there. So these are pull up resistors. They're holding the voltage up until we press the switch, then it's dropping the voltage down to 0 volts. So we have 5 volts to the input, and actually along this jumper there we got 5 volts to the input of the top input of that NAND gate down there. When I hit the switch, we have a 0-volt input there. So now what we need to do is connect the output of each NAND gate to the input that is not connected to anything yet. So doesn't matter which one we do first, we will plug this into the output. You can see the jumper there, and now the second input down doesn't have anything connected to it. That is where we connect the output there. And so why did that LED go off? The reason why, as you can see, the output is positive right now. It's pretty much spot on 5 volts. So that 5 volts is going to one of the inputs there. The other input has the resistor there that is delivering 5 volts to the other input. So both inputs are high. Since it's a NAND gate, the output is low. So one of the inputs of the one down here has a high signal. The other one has a low signal. So the output is high. We need both high for the output to be high, but one of them is low. It's actually floating, so it's not high. And it's not high or low, actually, it's floating, but it's not high. It has to be high. So what we're going to do, we're going to take this jumper to the output of that one. So now the output is low. We're going to plug that into the input there that does not have anything attached to it. So that one is the second one down. So it's in between that input and the output. And so nothing changed yet because that output is low. And so we have a low signal there. As long as both aren't high, if both are high, the output will be low. But if they are not both high, the output will be high, as you can see there. So now what we're going to do, we're going to hit the switch. Now you see the other LED is on, and it's staying on. That's because that output is high we have this output low. That output is feeding one of the inputs there, holding it low. Whereas this one's high, since we have this resistor holding one of those inputs high, and the output of this one is high, the jumper comes across to the other input, holding both inputs high until we hit that switch. It keeps bouncing back and forth. So they're feeding off of the output of the other one. And so whichever one has the output that is high, it's holding the other one off because they are NAND gates. When we hit the switch, we ground one of the inputs, which makes the output high. And then that output feeds a signal. This one hasn't been touched, so it's high. Now that's feeding that one high, and it turns that off. And you can keep going back and forth. So that is a simple flip-flop made with 2 NAND gates. So there's all kinds of schematics and stuff out there for that. I'm not going to draw one up at this time, so you can go out and look that up, but this is a way to wire it. That's pretty easy. So hopefully you understand all that. Thanks for watching, and I will see you in the next video.